So let's factor each one completely first. So look at the first one. Guys, I need you with me up here. What do you do? Take out a 5. What's left?
X squared minus 9.
Can I factor it any further?
Yeah, x plus 2.
Everybody okay with that?
100%.
All right, second one. 4x, what's left? Can I do anything else?
Yeah, you can break down this.
I can break down the what? The 4. Only the ones on the outside. If it's inside parentheses, you don't break that down. But the one outside, I'm going to break that down.
How come you broke down the 9?
Well, we broke that down into, y'all are being obnoxious today. Okay, LCM. Write the first one. The pen keeps not wanting to work. Now look at the second one. I have 2 2's. Do I need 2 2's? Yes, because I don't have any 2's in here yet. How about an x by itself, a lone x? I need it. How about an x plus 6? Yes, I need it. In this case, just like the denominator of 2 and 7 where we had to multiply them together to get the least common denominator, same thing here. So this ends up being what? Well, it's still got to be factored because when we add or subtract, we still need that denominator factored so we can cancel out. You want it, you have to go through the process to make sure it's the least common. Now, I mean, technically, you could every single time multiply the 2 bottoms together and get a common denominator, but your work is going to be so heavy at the end because you'll have to work so hard factoring to get it back to where it needs to be to cancel. All right, an x plus 6. So there's the LCD. Yes or no?
Is this all we're doing?
No.
I was about to say, that's really easy.
That's why I got started so early, because this was kind of... Okay. This is the backbone of it, okay? You have to understand how to do this to understand how to add or subtract. Y'all ready to give it a shot?
No.
Yeah. All right. Let's say I have... We'll start kind of easy. X over 3. All right, so I'm going to do you some little steps off to the side. I like the steps. If you don't like them, that's fine. 2, add. First thing I'm going to do is find the LCD. So the LCD is the LCM of the 2 denominators, right? So to find that, I first need to factor. All right, so this one, how does it break down? 3 times 3 times x times x. I want it completely factored down as far as I can get it. How about, what? What you mean? This is the problem on the left, but my first step is just to work with the denominators. Then I'm going to come back to the fractions. All right, how about the second one? How does that factor down? 3x. So 3 times x times what's left?
X.
Plus 1. If you factor a 3x out of these, you're left with... With me?
No.
If you take a 3x out of here...
Well, then why don't you just take a 3x out of the one on the left? Oh. Oh, no.
You sure? You with me? All right. So now, using these numbers, I want to find the LCM of those 2 numbers, which is also going to be my LCD. So I'm going to make that LCD, not LCM. Write the first one. Now look at the second one. I need a 3. Do I have a 3? Yes. I need an x. Do I have an x? Yes. I need an x plus 1. Do I have an x plus 1? No, so I'm going to write that here. So my least common denominator is 9x squared times x plus 1. Is anybody confused?
Wait, why don't you add another 3?
Yeah, I don't understand when
It's
you
on the
go
last
down.
one you added.
You only,
Twos.
okay, so that one had
You
two,
added two.
right, so each denominator has to be completely included in here. So if you just looked at this, does it have all of these pieces in it? Does it have a 3?
Oh, wait, it has it.
It has a 3, it has an X.
It has an x and it has an x plus 1. Does it have all of these pieces in it? It's got 2 3s, it's got 2 x's, yes. Putting another 3 would make you have a common denominator, not a least common denominator. You don't want any more 3s than what the one with the most has.
So basically, you're just putting it when it doesn't have.
Exactly, that's exactly what you're doing. All right, so here's the new part. Now, just like with the others, you have to make the denominators match the LCD. And what you're going to do is multiply by the pieces that it's missing to the top and bottom. Look at the first one. And sometimes it's a little easier to come over here and look at it factored. But if this is my LCD, 9x squared times x plus 1, what's missing from the first one? X plus 1.
Wait, what do you got?
All right, so this denominator has got to look like the LCD. So to make it look like the LCD, what does it need? X plus 1. So it needs an x plus 1, which means I have to also do it to the top, just like whenever I do the other denominators. Look at the second one. Okay, and this is where it may help to look at your factored forms. Okay, to make this 3 times x plus 1 look like that, what does it need? Another 3x. Top and bottom. So here's what I'm going to do. I'm going to write everything in factored form first. Yeah.
Why wouldn't it just be added and multiplied by another 3? If you,
Well,
if you factor into it, then it's weird.
the LCD has 2 x's on the outside. This one only has 1 x on the outside.
I have a question. You can't just make that 4x.
No, because you're not adding, you're multiplying. All right, so I wrote them in the factored forms, and then I added what was missing to it. Not added, but I multiplied by the missing pieces. Is anybody confused? I'm trying to take this really
So
slow.
what happened after you got them all on the same thing?
What?
Whenever you got all the fully broken down thing, and you made sure they were both in one.
Anything that it's missing, I multiplied top and bottom. This one was missing an x plus 1, so I gave it each an x plus 1. Okay, so look at it in factored form. Look at this as 3x times x plus 1. And now what do you need to make it become 9x squared times x plus 1? Yes, Ty,
I would
do
like to know, how did you take the 3x times x plus 1 on the right and compare it to factor the LCD?
Because I've got to, both of them have to become the LCD. So I need to know what does it need to make it the LCD. Yeah.
So with the 7 and the 9, just add the x plus 1 on the side.
Right.
So with the 3, put the x plus 1 not the
For the what now? For this one?
It's on the bottom. Yeah, why is it the same as the one that's the other one?
This is factored form. I just factored it so that you can see it become, it's going to become 9x squared times x plus 1. It's a little easier to see in factored form the factors that it's missing.
Miss McGee, can you go back to the slide like that we were at whenever we installed
Okay, so does everyone else understand? Are we all on the same page how we got to this?
Yes.
Okay, now that the denominators are the same, I can add the tops. I told y'all this was a loaded lesson. Be prepared.
Oh my God, all that.
Oh my, I can't put my arms out of my.
Now, when the guys, I'm up here, still teaching. Y'all ready? I have 7 times x plus 1 plus x times 3x, and I'm going to put it all over. These are the same, so I'm going to put it all over 9x squared times x plus 1. Now, do not, and listen carefully, do not start marking stuff out
Still on the
yet.
same problem?
Yes.
Here is why. You see that plus right there in the middle?
Yeah.
It is not enclosed in parentheses.
Jesus.
Until, Ben, listen, this is important. Until every single plus or minus is enclosed in parentheses, you cannot start canceling out.
I don't know what that means.
See, this one's enclosed in parentheses because it's a factor. This one's not inside parentheses.
But that's a plus.
It's a plus. Any plus or minus that's not in parentheses means I cannot start canceling out.
That makes the plus sign in parentheses.
Yeah, like this. Not plus by itself, but x plus something or x minus something. Okay.
What happened to the 3x, x plus 1 times 3x?
3x times x plus 1 times 3x. 3x times 3x is 9x squared. Times x plus 1. These became
Oh,
the
yeah,
LCD.
that makes sense.
This LCD that you come up with is what both denominators become.
Yep.
That's what we forced. That's what we made.
It's just like you do the hard way.
Okay. Guys, I need you with me. We're not done with the problem. Now, I'm going to expand the top. I'm going to leave the bottom. The bottom is already completely factored. Every plus or minus, there's no plus or minus outside of parentheses all alone, like there is up top. Okay? So up top, I need to expand. How might I expand up top? Look,
Expand.
7x
That's condensing though.
plus 7. No, you're thinking logs. I'm not logging it right now. I'm just, right now I want to get it multiplied out so that I can try to factor it down. To get the plus in parentheses. That's my goal. Plus, x times 3x is 3x squared. So if you look up top at this point, I'm going to try to rearrange it and factor. Because it's a quadratic. That's exactly right. So after I expand the top, I'm going to factor / simplify. Think about this as being a problem like you did last night. If you have 3x squared plus 7x plus 7 over 9x squared times x plus 1, how might you simplify that?
Box.
I'm going to try to box it. I don't know if this is going to box or not. Most of them will not, and most of them will already be simplified. So Anna says it doesn't. Does anything multiply to 21 but add to 7?
Yes.
What?
Not 7 and 3 and not 21 and 1.
And so this problem is done.
That's right.
Okay, I know. All right, x plus 2 over 2x minus 2. Ben, it would be very beneficial if you would pick up your pencil and write this down. Negative 2x minus 1. Matthew. Over x squared minus 4x plus 3. Tell me what to do first.
Oh, factor.
Factor. Factor is always, always, always the key to these problems, okay? So I'm going to come off to the side because I'm factoring, actually, I'm going to go ahead and factor this. I'm going to put x plus 2 over, how do you factor 2x minus 2? 2? I am.
I don't get how you just did that. I don't get it.
Take a GCF out. They both share 2. You can divide them both by 2. Shh, Matthew. All right, look at the second fraction. Look at the denominator.
X plus 1 and x.
Banks. X
X minus 1 and
x minus 1, x minus 3. All right, let's come off to the side. Our LCD, which is the LCM. Write the first one. Lost, Tashawn?
No.
I thought you said so lost.
No,
Okay,
I'm
okay.
very
You with me?
with you.
Okay.
I'm with her.
Okay. You've got 2 and x minus 1. Now look at the second fraction. What do I still need to add to the LCD to make it include everything? X minus 3. Good job. Does everybody see where those pieces came from? Okay. Come back over to the fraction. Look at the first fraction. What does it need to match the LCD? What is it? X minus 3. X minus 3. Look at the second one. Matthew. 2. Okay. Now I'm just going to rewrite this so that you can see. I have x plus 2, x minus 3. Be very careful when it's subtraction because you need to understand I'm subtracting everything in top of that second parenthesis. 2 times negative 2x minus 1. And I'm going to go ahead and put everybody over that LCD, right? Because now the bottoms match, and as soon as the bottoms match, because I wanted you to see that what I'm doing is I'm subtracting in everything that's in the top of this. So what I should really do is simplify first and then subtract.
So what you're just doing is getting the bottom the same so you can compare it.
Yep. Just like you would if it was numbers, it's just now the factors are much more complicated. Okay, here comes the slightly more difficult part. I need to expand out that top. I need to multiply out that top. And I'm going to multiply it out so that I can bring it back in. I got to FOIL it. You're absolutely right. X squared minus 3x plus 2x minus 6 minus, I'm going to go ahead and distribute that 2, negative 4x minus 2. Everybody goes over my LCD. The good thing is the bottom, I've done all that work for the bottom and I don't have to touch it anymore.
And if we plug that top thing into the calculator, will it do that for us?
No.
These are bum calculators. They're like $100 and I can't even do this kind of math. Is that not like boggling your mind?
Okay. I am going to go ahead, since I can do this all at one time, I'm going to change this to a plus, and I'm going to change all the signs that follow it.
Same.
That way I can go ahead and combine all my like terms so I don't have to do more than one step. So up top I have an x squared. I've got negative 3, 2, and 4. So that'd be 3x. Is that right? Minus 4. I'm just combining like terms across the top then. I had negative 3x, positive 2x, and positive 4x, which gave me 3x. And then I have minus 4, and all of this goes over my LCD. This one, however, is factorable. Look at the top there. How does it factor? 4, negative 1.
Put the top one in the box.
X plus 4. Put it in the box. Yes, Matthew.
Yup.
Now look, and I want you to see the difference. Look here. Look between these two. This one, see this minus sign that's sitting out all by itself here? Now every minus or plus that I have is enclosed inside parentheses. It sits in the middle. Now I'm ready to cancel out.
Wait, so Miss McGee, whenever,
Yes, David.
whenever you change all the signs, you started at that minus sign with the thing.
Mm-hmm. That one had a nice cancel in it. Once it found.
So we
All
have
right.
to do this one, right? Since you're here.
Oh, wait.
You do, so you better copy it.
Crap.
Copying is cheating, Steve.
I am working backwards.
Minus x plus 3 over x plus 7. So again, this is number 24 from your homework. We're going to do together before I set you loose. All right. You will find, as you look at this, you might go, yes, that doesn't factor. Yes, that doesn't factor. But sometimes that makes it harder.
Yeah, because the x squared minus 5 is weird.
Yeah. All right, so looking at the denominators here, I'm going to factor this one as what? 7 and negative 2. X plus 7, x minus 2. Now, you might, I've done them a couple different ways where I've come off to the side and wrote them, or I've rewritten them. You'll find your own little niche on how you like to work the problems. I like to scratch it out so I don't lose track of what goes with what, and I like to write it right. But if that confuses you, you do it your way. All right. Does somebody have a question? I thought somebody's hand. Somebody raised their hand. No? Okay.
How do you just go straight to that?
When the leading coefficient is 1,
She's not drawing the box. She's just doing
when the leading coefficient is 1, the factors that you would put in the box are the factors that go here.
Factors to go where?
Right here. Like if you were to draw that box out, you would have x squared negative 14. What multiplies to negative 14 but adds to positive 5? 7x and negative 2x. So the 7 and the negative 2 is just the little shortcut for whenever. It only works when it's just x squared in front. Okay. So LCD. Tell me what the LCD is.
X plus 7 and
X
x
plus
minus 2.
What?
Right?
Yeah.
What do I need on the first one? Ooh, nice, right? Nothing. How about the second one? X minus 2.
So
You're talking about the numerator on this first one?
The denominator. I'm talking about what does the denominator need in order to match the LCD? To make the bottom look like this, what do you have to give it? All right, so now I have x squared minus 5 minus, and again, I'm going to do my brackets here because I want to make sure that I subtract everything I'm supposed to subtract. X plus 3, x minus 2, and everybody goes over that LCD. Anybody lost? Everybody with me? Let's start multiplying out that top then. So I have x squared minus 5 minus, I'm going to just FOIL this out. Everybody over the LCD.
Oh, someone's up.
Let's change all the signs.
Well, we did this last time.
No, because I just would combine like terms there. I'm just changing all the signs. You could combine the terms before you change the signs if you wanted to. All right, so now let's look up top. This is nice. Those cancel. X squared, negative x squared is nothing. My x's, it looks like I have negative x. And my constants, 1. X plus 7, x minus 2, and I can't factor anything any further, which means I'm...
Miss me, those sheets
That
are,
one wasn't hard at all.
those sheets were good.